Welcome back. We are continuing to go through our RISC-V assembly instructions. We have covered two instructions so far, add and sub, that perform addition and subtraction over the contents of the registers inside of a processor. We add assembly instructions to a processor to support common cases that we find in higher level languages. So one thing that we frequently do in higher level languages like C is we add a constant to a variable. So there is a special instruction that does this addition of a constant to a variable. Numerical constants in assembly are called immediates. They appear often in the code, so it does make sense to have support for them in the assembly language. The instruction that RISC-V uses for adding immediates is called ADDI, which stands for add immediate. It makes sense that it is called that way because in a catalog of instructions, so in a green card, add immediate is going to be standing right next to the register add. Its format is also very similar to what we have seen as a format for the add instruction. Instead of having add, destination register, source 1, source 2, the format of the add immediate is ADDI, destination register, source register, and the value of the immediate. It looks similar to the add instruction because we do want to reuse actually most of the hardware that we'll be using to build this processor to implement these two instructions. A few other interesting things about the RISC-V and the immediates. Although there are separate add and sub instructions because sub instruction, substitution is not commutative, so it makes sense to have a sub instruction. There is no sub immediate. I'll give you a second to think about why we don't need sub immediate in assembly. Got it? Of course. Well, because we really don't need it. We can implement it, we can replace it by using add immediate, where that immediate would be a negative value implemented into its complement in RISC-V. So our instruction that would implement f equals to g minus 10 in C would look like add immediate x3, x4 minus 10 is to into its complement in RISC-V. So we don't need it. Notice though that if we wanted to implement f equals 10 minus g, we would need two instructions to do that. You can think about how to do that. Keep in mind that the most common immediate that we are going to encounter in code is 0. That's why it makes sense to keep that 0 handy inside of a processor by hardwiring one of its registers, and in the RISC-V it is the X0 register. So no matter what you do to X0 register, it always holds the value of 0 because processor does like to have a 0 handy at all times. So if you do things with X0, keep that in mind. For example, add X3, X4, X0 would simply move the contents of a register X4 to register X3, like f equals g in C. Now, we can try to use the register X0 as a destination register, but that doesn't make sense. Because if we say that add, if we write an instruction, add X0, X3, X4, no matter what the value or what the values are stored in the registers X3 and X4, this instruction will not change the contents of X0. X0 is going to stay 0. And that's it, what we have to say for now about the immediates. Now it's a good time to take a little break because we're going to get into slightly different instructions in the next segment. See you then.